In this experiment, you're going to arrange a collision between two plastic discs. The large one we call the target, the small one we call the target, and the large one we call the striker. So you're going to shoot the striker at the target, and you're trying to make a glancing collision, arrange a glancing collision between the two discs. Now, here is a camera, and you can use such a camera to record or make a video of the collision. And afterwards, you're going to download the video on a computer and analyze the collision with some software installed on the computer. You can use your cell phone if you want to, but you'll just have to hold it there. Use your cell phone if you wanted to make a movie of the collision. Now, let's see if I can arrange such a collision. That's a bit, we want this one to deviate a bit more. So let's try again. It takes a few shots to get things right. And you want to shoot quite hard, not soft. You want it to. That's reasonable. And then you would stop the recording. So we've arranged the collision between the two discs, and what do we want to determine or analyze regarding this collision? We want to see if the momentum before the collision is the same as the momentum after the collision. Now, momentum is a vector, meaning it's got both magnitude and direction. So we've got to take the direction in which the object is moving into account. More specifically, you are going to represent the momentum as arrows in your report. Graphical arrows. The length of the arrow tells us how much momentum the object has, and the direction in which the arrow is drawn indicates the direction of the momentum vector. Now, so we want to see, is the momentum before the collision the same as the momentum after the collision? Now, before the collision, you've only got the striker moving. So we've got one momentum vector. But after the collision, we've got two momentum vectors. So how is it possible that one can be equal to two? That's not possible. So what you're going to do is you're going to determine the resultant momentum of those two vectors after the collision. You're going to combine them and get their resultant momentum vector. So that resultant is then actually the same as, it can actually replace those two momentum vectors. And then we can compare these two momentum vectors. Is it the before momentum vector the same as the after momentum vector? Are both their magnitude and direction the same? So that is, in short, what you are trying to do with this experiment.